welcome. Thanks for joining us. We appreciate having so many of you here. This is fantastic. We'll get into introductions in a minute. Some of you have already jumped to exactly what I'm going to ask you to do in just a minute, but this is our webinar on our Yes Enrichment. So unlocking STEM potential through informal learning. And our agenda for this evening or morning, wherever you are, I think has to be daytime over in Thailand. I was just talking to Australia. I know it was morning for them. So our agenda for today is we're going to do some introductions. We're going to define what is it that we mean by enrichment STEM. We'll talk about some of the key principles of Yes Enrichment that help us with our enrichment spaces. And I thought I'd share some case studies of enrichment programs. So how are people successfully using STEM in these enrichment spaces? And particularly, how are they using the Yes engineering enrichment curricula? And then we'll wrap up and have time for Q&A and a little discussion. So as we get going, if you wouldn't mind, some of you already did, you got ahead of me on it, and I love that. Share in the chat, where are you from and what kind of program do you teach or support? And so we can think about what are some of these spaces that we're thinking of as enrichment. To give you a little introduction to me, my name is Katie, as it says on the screen. I'm a professional learning and research manager with the Museum of Science, Boston, but I am located actually in Center County, Pennsylvania. So moving things along. Right here in the middle of Pennsylvania. I am a former Pennsylvania public school teacher. More Australia. I love it. I just got off with people from Deakin, Sue. So great to see so many different locations and spaces. Yes, the person saying they're freezing from Michigan, agreed. It is also very cold here in Pennsylvania. Let me see, 19 degrees Fahrenheit. So the person joining from Costa Rica and Australia, we'd all like to come visit you in those much warmer climates. So thank you for sharing all of these spaces and locations. This is so exciting to see. Liliana says a chilly 52 here at home. I will take your 52 in any day. So many different spaces. I love it. Great to see. I'm going to keep us moving here. We're going to come back to the chat and interact with each other as we go to sort of make this, again, more interactive. Oops, let's try that again. I just gave it away by hitting too many buttons. But I wanted to start with defining what we mean by enrichment STEM. So, what is that? What does one do? What does that mean? Because it tends to have some different definitions depending on where we are. And we're going to kind of look a little bit at also what does this Yes curriculum do to help support those kinds of things. And so enrichment contexts are extremely diverse and varied. We can see that in the chat, the many different kinds of things that you all are doing to support youth. And we use the term enrichment as these spaces are supplemental often to the formal, standards-aligned, tested context of the school day. And this can include your STEM courses that I see many of you are teaching. It might be after school clubs at school or at libraries, other informal spaces like our own Museum of Science, STEM centers, or groups like Scouting, Girl Scouts, Boy Scouts, Girl Guides, I think those are still a thing. And these spaces provide a really unique opportunity to support youth in accessing STEM learning that they might not have during their structured formal science learning time for a variety of reasons. And these enrichment spaces really have some opportunities. You all have such power to help formal learning close gaps in access and achievement in STEM that's caused by inequities in gender, in race, in socioeconomic status. And it's highly beneficial for youth to engage with STEM because it helps with their socio-emotional learning, it helps them develop STEM identities, and increase their STEM achievement in the regular school classroom. And there's lots of research that can back up these claims, as you see the very long list of citations at the bottom of your screen. But even with all of these benefits to engaging youth in STEM, there's still a lot of challenges that you all, I'm sure, are very well acquainted with. So looking at more of the out-of-school time, at the program level, 76% of out-of-school time programs in 2021 were offering some kind of STEM programming to youth, which is great. But unfortunately, only 30% of that programming included engineering in any form. Excluding engineering means that the benefits of all that STEM education that we just talked about on the slide before might not be fully realized in those programs because youth don't have the exposure to the practices of engineering or the engineering careers that might help them develop those engineering and STEM identities. And we know that there's a lot of barriers that are causing some of these things to happen, right? One reason is programs may not be bringing engineering in because educators may have never learned about engineering or how to teach it. It certainly was not something my teacher preparation course covered. But enrichment-based educators may also not have even been formally trained as teachers. A lot of times they're great volunteers who have STEM backgrounds, who maybe want to do outreach, who want to support youth in getting engaged with STEM, but aren't formal teachers. And the opportunity for educators to learn about engineering is often limited, both in the availability and in the time and the resources to get educators to the professional learning that is available. And so these webinars are one way that YES is trying to help enrichment spaces provide youth with engineering experiences. And so I thought we'd talk a little bit about how we can help with some of those challenges. So Youth Engineering Solutions offers ways these enrichment programs can increase use. Oh boy, we're going to stumble over words again today. Can increase youth's access to engineering and computer science learning spaces. One way is that our curriculum is free. You can go download it on our website right now, including all of the digital materials to support students in engaging in engineering design challenges. The other way is our professional learning opportunities like our free webinars, and coming soon, our asynchronous learning library, which will feature classroom videos and reflection questions around key components of the engineering practices and our equity-oriented framework, among others. So we're going to share a sample of how these things can support you as an educator in bringing STEM into your program. So each YES enrichment unit has an introductory engineering design challenge, 4 activities that make up the core engineering design challenge, and then 4 optional activities that complement the unit's core engineering design challenge. So for example, what you're seeing here is 2 pages from our teacher guide or educator guide from Engineering Rescue Shuttles, a middle grades, intermediate level engineering enrichment unit. And we see the introduction to the engineering design challenge asks youth to design a pencil case. Then youth design rescue shuttles or stomp rockets, if you've ever seen those, that's kind of the gist, to reach specific people who need rescuing from weather-related flooding. The optional activities then have them design a waterproof bag for these kinds of rescues, a glider that can deliver supplies to stranded people, an exploration of STEM careers, and a showcase to highlight their learning and designs to families and the community. In this educator guide, each lesson has its own guiding question and learning objectives and identifies the focal engineering practice. We'll talk about practices a little bit more in just a minute. There's also lesson-specific materials list, preparation instructions, and within the actual instructions for the activities, we provide suggestions for effective questioning to prompt students to think more deeply, reminders of things you might want to know in the moment, those just-in-time reminders, and tips for implementation and where equity is embedded in the design of the lesson. Another support that makes this helpful for educators is our educator slides. These pre-prepared instructional slides help educators focus on the important part of teaching, the youth. These are useful if you have access to a projector. We know that not every setting will. You can share a lot of these same resources as print format, send materials to students' devices. The flexibility is built in to support students and youth in the programs that exist, rather than trying to fit your program to a specific curriculum. Another support is that we have these engineering notebooks that are really helpful for helping students track their design challenge over time. We see some samples here of real student work from across the phases of the engineering design process. Out of school time, other enrichment spaces, often our youth are coming sometimes inconsistently, sometimes we only see them once a week. Having these sustained design challenges can pose a challenge to these enrichment spaces, but having a way for students to track the exploration of materials, to document their developing designs, their testing data so they can improve, all of those things make it really helpful for youth to have that consistency that allows them to continue to be successful in the engineering design process. And so another way that we try to be really supportive is that we recognize that engineering in preschool and kindergarten and engineering with 8th and 9th graders should look differently. We use a developmentally appropriate engineering design process with less steps for preschool and a more sophisticated process at the middle school level. With students in K-5, which we see in the middle, we think about asking questions, imagining ideas, being creative, planning designs collaboratively in groups, creating and testing those designs to improve them. We see this as a nonlinear process. Students will move fluidly between these different phases throughout one of the units, even though specific stages are highlighted in each activity to support educators' facilitation. So you know what the focus of that lesson should be. And to help ensure access, we think about equity-oriented engineering as the foundational model of curricula. The model has 4 domains, each of which encompasses design principles that structure the resources we develop for all of our programs. The model communicates how engineering learning can be developed through more equitable approaches. Carefully designed curricula facilitate youth's participation in socially engaged engineering relevant to their lives, community, and world. And through analysis and design regarding these applied problems, youth use engineering knowledge as they engage in the engineering practices. This participation and engagement are facilitated by asset-based pedagogies, focusing on the strengths youth bring to the engineering contexts. The model depicts the development of a positive, generative engineering identity that is built on substantive learning of engineering knowledge and classroom discourse that situates youth as competent and engaged engineers. We'll visit each of these different domains throughout this webinar, but we'll start with thinking about what might it look like for students to develop a STEM identity, and then we'll circle back to that one at the end. So this is where I might ask you to start using the chat again to talk with us. But in this video, you'll see 2 youth engage in the initial planning stages of the engineering design process. So use the chat. What are you noticing? What aspects of this interaction are supporting students in developing a STEM identity?
I'm looking at you. I'm gonna collect your packet, and I'm gonna look at your design. So there'll be a design on your page. That's your exit ticket. Your packet. This is your exit ticket out of class. I'm collecting your packets and I'm looking at your design. Your design on the page. This is your exit ticket. I don't know why you have on your design.
Yeah, sorry, Lisa. It is a little hard to hear that video. The audio is not great. There should be there's always transcription at the bottom of all of our videos, because it's often a lot of hard to hear. The thing about engineering context is that students often get loud and get excited, so sometimes it's hard to hear them over top of their classmates. But we see a lot of collaboration. Lara says demonstration, testing, discussion of the design, absolutely. Deductible reasoning. We're seeing a lot of these things start to emerge in just this short little bit as they work together. They're not even making their design yet, but you'll notice that they pull on all of their assets to do this. They're not just speaking to one another, they're gesturing, they're manipulating the materials in order to get to where they need to get to. And so the YES curriculum framework is designed to support youth in developing these STEM identities. Here we see the students using their home language to fully engage in discussing a plan, thinking about the criteria and constraints and the properties of materials. They're working well as a team. They're communicating with one another to design an innovative solution. Right, we see collaboration again in the chat, identifying improvements. Absolutely, they're building on each other's ideas. Making it so that they are working together to come up with a solution using all of their assets. Nope, thank you. So authentic engineering practices are just throughout the curriculum. This is core. And they're highlighted in each activity to help educators foster these engineering practices with youth. We'll take a closer look at a few of these now and how we see them in our enrichment units. We can't get to all of them for time, but we're going to highlight a few of them. And so to engage as engineers, students need to understand what a technology needs to do to be successful. Engineers think about criteria, which are the requirements and constraints, the limitations of the design, and balance trade-offs between these. Similarly, student designs should be guided by a clear understanding of the task. Generating a list of criteria and constraints through investigations or research and posting this for reference can enhance the youth's design. So making it clear to them what the expectations are. In some engineering challenges, some criteria and constraints are set by clients or users. In one of our upper elementary units, students think about how to design a sock assistive device, how they can design for someone who has physical challenges, temporarily or perpetually, in putting on their own socks. For many students engaged in this sock assistive device unit, their body doesn't restrict them from the process, so we have to set criteria, what the device needs to do, and constraints, which help the students model the user, such as not bending their knee when they go to put the sock on. In other challenges, students themselves articulate some or all of these criteria and constraints. As new questions arise about the challenge and the new parameters are negotiated by the class, they can be added to the list of criteria and constraints. Even with these criteria and constraints, because sometimes people will say to me, but then we're limiting what they can do. No, the design's still open to interpretation. We see here a variety of sock-assisted devices crafted by youth in different programs. And much like engineers, the students have found more than one way to solve a problem. Which takes us to highlighting an important engineering practice. Engineers tackle open-ended problems that rarely have one solution. Engineers envision a variety of ways they might approach or address the problem and consider the criteria and constraints as well as the client's needs. Many design solutions coexist and designs evolve as engineers envision a next generation of possibilities. The opportunity to design something original makes engineering really interesting and engaging for youth. Design challenges with many different solutions also foster creativity, problem solving, and innovative thinking, things we want youth to do in and out of our STEM programs. Many teachers and educators have recounted stories of students who check out during conventional school activities. And we'll hear some of this from educators at the towards the end, that have checked out during our conventional school activities that have a correct answer, but they're really drawn in and engaged and flourishing in the engineering context. And so just to give you an idea, these are waterproof bags from our rescue shuttles, and then those are rescue shuttles themselves. There we go. With those multiple solutions, not every design works the first time. Real engineers know and embrace the idea that failure helps you learn what works. Engineers learn from failure to revise and improve designs, and this requires perseverance and improving through multiple iterations. An engineering process with a built-in improve step can signal to youth that they're expected to try again. As you can see from these quotes, youth embrace the opportunity to hone their thinking and work on new solutions. And I'm seeing a quote that we did the slipper unit and they turned out better than the examples. We would love to see photos. We love hearing from people who are using the materials and how it's working. We love critical feedback. And so we're going to go back to the chat again. And I want you to think about your own educational context. What are some ways you see these practices benefiting youth in your program? What about engineering practices might help youth in STEM, out of STEM? Why might these be helpful for you to bring into your classroom or your program? We'll give everybody a second to kind of think that one through and share those out. Gave you a couple of hints on the last slide about some of the things that I think that they do. Yeah, so Peter mentioned that it enables those who don't usually participate a chance to. And this is the thing that I have seen repeatedly. I get the privilege of spending a lot of times in classrooms with teachers. I'm in a first grade classroom right now. And yes, they are absolutely up and moving. But more importantly, we often see our students with IEPs, our students who are identified as needing English learning support, our students who are labeled neurodivergent, who often, and we'll meet one of those students in a little bit, really seem to just enjoy what they're doing. Critical thinking is absolutely one of those things. Yes, absolutely. Let's get them expressing what they know in different ways is really, really important. Learning how to work on a team. This is another one that I hear echoed by educators who say, I wish I had started doing this sooner. They're talking to each other now. Absolutely re-engaging those students when they can bring those outside experiences in. I'm hearing that, right? Engaging all students, increasing problem-solving skills, 100%. So we see there's a lot of ways that these practices can really help our students, not just in STEM, but just in their overall being. And yes, learning how to fail is a huge one. Not at the total center of this particular webinar. It should be its own whole thing. And so another way we help students to see that engineering impacts our society and our world is to design curriculum with socially engaged engineering in mind. And we've distilled 3 design principles that go into each of these units, and you can see them here. Situating the problem in a societal context, considering the impact of the problem on different individuals, groups, or systems, and thinking critically about the impacts of engineered solutions. There's many ways students can forge meaningful connections between their lives, communities, cultures, and society and engineering. Stories are one powerful tool for situating a problem in a larger context and understanding its importance. And so this context setting is key to Yes's model for how we think about things. Why do we need to design this thing? In early elementary, a story is read aloud to students with an interactive poster. We see an example of this in the upper left corner where Zoe and Ayana are trying to design a sail to send their toy scoobles between their bedrooms. This is a made-up term, but you'll see the scoobles in the bucket there. They're awfully cute. Upper elementary students read a graphic novel format, a comic format that can be used as the teacher sees fit. Students we've seen read silently and then have a discussion. They can read aloud or even act out the story that's being portrayed in the illustrations. Videos are also useful to help youth situate the problem in their own lives. For example, in the bottom left, we see video used in our engineering rescue shuttles to help youth understand the context of one of the optional lessons where they're designing their waterproof bag. These tools also help educators support students' literacy skills as they read along, make sense of the stories, and discuss how the stories in the design challenge are connected. Some of these aspects of socially engaged engineering might seem a little daunting if you work with our younger learners, but each component we break down into developmentally appropriate progressions. And so, okay, what then does that look like with our younger learners? We're going to watch a video here of a first grade student who's been working to design a nightlight that works for different kinds of users with different needs. Hopefully you can hear this one because there is not subtitles.
So I chose this one because it's the lightest, but we can still use both because if the person isn't that scared of the dark anymore, they could flip it upside down so the light is here and then it'll just shine here. But if they're really scared of the dark, they can go it like that and then it'll be like that.
Students are thinking about the impact of the problem on different individuals. Here it is as simple as thinking about needs or preferences, a vocabulary word introduced to the unit, people might have, like sleeping with or without a nightlight. The challenges are designed to have them thinking about these things as part of the design process, that there will always be trade-offs. Well, every time. The third dimension of the framework highlights our asset-based pedagogies, ways in which students can be viewed in a positive light, as having value which they bring to the table in engineering classrooms. This includes building on their experiences and knowledge brought from non-school contexts, supporting their developing vocabulary related to the engineering design process, and the challenge to, excuse me, to open opportunities to use that knowledge in disciplinary aligned ways, and creating design challenges and accompanying materials that provide multiple ways for youth to share and document their designs. In this video, youth are working on a design challenge around rescue shuttles, as we talked about before, and they've been reading the comic that we just talked about in our socially engaged, and the comic is helping to frame the problem, why these rescue shuttles are needed. Here, students connect with the story and relate it to their own experience of the flooding in their own community and the neighbors who needed to have rescuers come to their aid. This is another one with a lot of translanguaging, so you may want to follow along to the subtitles on the bottom that will help you understand what's being said.
No, this case, by the way, this happened a lot in the Hurricane Maria, happened a lot because especially near us, remember the flood of the Rio Añasco? Remember the river? That a lot of neighborhoods, their water went so tall as more than 8 feet.
En la casa de mi papá, so, los vecinos de nosotros, they told us que la mamá estaba en una llamada y el nene estaba jugando, el nene estaba recogiendo todo lo que estaba afuera y después él mira algo y hay una ola gigante, más grande que la casa de ella, de ellos, y él grita una ola y ellos salen ahí.
They were rescued. rescuers were trying to cut them.
Okay. There we go. And so the final dimension we've sort of started with and we're ending with is that educators can nurture their engineering identity in a number of ways. Successfully participating in engineering design challenges shows youth that they're capable of engaging in such work in and out of your enrichment spaces. As youth engage in engineering activities, educators can make connections between the work they're doing and that of engineers. For example, they can refer to the work youth are engaged in as engineering, the youth as engineers, and that helps members identify their efforts in that way. And so in this video that we're about to see, a teacher's going to share first some background about a student before he expresses how he feels about engineering.
He is a student who struggled a lot with English since Greek. Seeing him reading English confidently, everything, and seeing him so happy because his struggle went through this, and seeing that he created something that it went perfectly, he was super excited about it. After that shuttle, the next day he was more confident in what he was doing.
What do you really like about the rescue ships or the cohetes?
Everything.
Everything. Tell me
Everything.
more. Tell me more about what does everything mean?
All the things.
All.
I like where I think I'm gonna be un ingeniero because I like all of the things que tienen que ver con electricidad, con cosas que dan vueltas, cosas que prenden como las luces. A mí me encanta todo lo que tiene que ver con ingeniero.
So you like the engineering aspect of it, and you think about other areas of engineering.
Yeah, I like airplanes.
You like airplanes? You said you like something about electricity, electrical engineering. Do you think you want to do this type of activity again?
Yes.
Yes?
Totally yes.
And why?
Because it was super
fun.
cool.
I love engineering.
I like to be like different things every day. I want to meet new people. I like to prove new things. I like to saber más ingeniería, sobre ingeniería, todo lo que
Yeah.
yo me levanto y digo, ay, ojalá que aprendamos algo nuevo en ciencia.
And so for many students who experience challenges with the standard classroom, your enrichment programs have the potential to support students like this with their engineering development, their engineering identity development, excuse me. It's the culmination of socially engaged, exciting problems to solve, asset-based pedagogies that invite students to use all of their resources to participate in authentic engineering practices that helped this student to see himself as an engineer. Weaving these components together allow all students to be engineers. Yep, every time. And so it's one thing to talk about the materials that are there, the resources that are there for you, but hearing how it's played out in real times in programs can be really powerful, thinking about how your programs can benefit from engineering. So I thought I'd give us two case studies. So the first one, and you'll see quotes from educators from the program on the screen. Those are students from the program, was in Chelsea Public Schools. So Chelsea is a school district just outside of Boston, for those of you not familiar. And it's one space in which the Yes Enrichment materials have really made a difference with both youth and educators. And so we'll see, like I said, we see some quotes here from the educators with Chelsea's after school program who began using the Yes materials with emergent multilingual learners in their district. The Chelsea program was able to pilot test actually our early versions of the Yes Enrichment materials and give us critical feedback to inform the unit development. The youth in the program were so enthusiastic and they shared this with parents, with families, with their community. And it created a demand for more offerings for both more EMLs within the community and non-EML youth who wanted to be engaged in these engineering activities. They expanded to more after-school offerings, a spring break acceleration program, and a summer enrichment program. And it's continued to grow. And Chelsea is even now using the Yes in School Elementary in their science and STEM programs during the regular school day. And so all of these quotes are from educators who are part of the program. They were acutely aware of the more structured and standardized classroom that youth experienced during the day and saw how excited they were to come to something unique and exciting after school. Another program is here, right here in Pennsylvania, about an hour west of where I'm sitting with you, my grandmother's hometown, of Altoona, Pennsylvania. And this particular program was called Team Builders, and they support youth in an after-school program that's at a county center that supports people with disabilities. Youth in the program were upper elementary and middle school. They came from a variety of different public and private schools in the area. Some participating youth had disabilities themselves, but it was not a requirement to be in the program. And what the teachers found is that students who participated in this program were able to reframe failure and success and see positive role models of people with disabilities, how we're all different, and minimize the binary between people with and without disabilities. And so we'll let Marty and Jacob, the instructors, the educators in this program, tell you a little bit more about why it was important for them and the people in their program.
In my heart,
Ooh.
I was
Very quiet. Give me 1 second. There we go. Try again.
applauding the fact that people are using disability language.
Yeah.
Instead of people that are different and what's wrong with her, that kind of thing.
Tell me about the water tower. High low. If you're short.
You reached that one.
I
Short.
can reach that.
You can reach that.
Yeah.
Yeah, try to use the-
Right, Nicole got it,
Going from hearing the word
Oh.
being used handicap at the beginning to hearing accessible. And that also includes
for-
families
Yeah,
and gym members.
that was big on the, when we were going around, is this accessible, do you think, would this be inaccessible, and it really got it through to them, like, I
Mhm.
think, yeah.
Yeah, I already read that. There we go. So to wrap us up a little bit, currently we have 4 Yes Enrichment units on our website you can download right now. 2 of the units, Engineering Bandages and Engineering Sales, which we see on the right side of the screen, are geared for our lower elementary grades, youth aged 5 to 8, give or take. Youth engage in developmentally appropriate problems using the interactive story posters to solve problems the characters, who are also of that same age range, are facing. In the upper elementary units, engineering sock-assisted devices and engineering rescue shuttles, youth age, let's say 8 to 12, right? There's definitely wiggle room there. Think about bigger problems like helping people with disabilities be self-sufficient or aiding rescue workers and helping people get to safety. These socially engaged problems help youth see a reason to develop a solution to the problem. And these are just some of our Yes Enrichment units. They're all available to download right now, and 2 more are coming very, very soon. We also have the entire suite of the Engineering is Elementary enrichment curricula as well.